Welcome back to yet another video. Today we are going to discuss about the topic related to microservices and also a distributed applications. So there is a concept called 12 factor app methodology. So this is used when you are want to scale and robust your application, that is your microservices. So in that case, you use this particular. In this video, we will discuss what are the 12 factor apps methodology, and we will discuss in details, and also we will give you the full explanation. So without wasting time, let's start. So the 12 factor app, actually what exactly it is, a best practice basically. Okay. So whether you want to do this, build a software as a service, service applications that should be scalable, maintainable and deployable, right? So that kind of applications, we can use this particular 12 factor app methodologies. Now this this was originally introduced by Horiku. So it was a guide for the development of an application that will be either running on the cloud, and I mean it should be modernized, distributed, or microservice based application. So basically for this kind of application, this particular guide was maintained. Okay. Now what exactly this particular 12 factor method is? It actually focuses on like the how the structure of an application for the cloud should be, and how it can be easily deployed and it can be managed easily. Okay, so these are the key factors which was looked into, and from by closely monitoring this actually, or closely checking, these are the 12 factor apps which came into picture. Now the very first thing is code base. Now you should have per application one code base. Why? Because your application should be accessed by multiple people, right? So, and it should be same for multiple environments. So what this particular single code base, which will that can be deployed to the multiple environments. So it's whether it can be staging, production, feature. So the code base stored should be stored in one of the Git, that is version control repository. So you can choose any of them, but one of them is Git. So it's a version control repository basically. Okay. So that's the key aspect of it. Okay. So the same code base, whatever it is committed in that particular Git base, should be deployed in different environments, because it will have a different configuration, and that are specific to their environments. Okay. So let's say that the dev environment will not have the same configurations to the production, right? There will be a different username and password, and a lot of configuration may vary, right? That's some settings can be done in it. Okay. So when you're doing in a microservice setup, right, basically, so you have many services, right? So each of its own will have its own repository, right? So or let's say all the services should be in a different repository, right? So that's how it is. It should be maintained. This with this actually they can be independently versioned and actually independently deployed. So there is no tight coupling or restriction on the other team whether we have to touch it or not, right? So every application will have their own repository dependency. Now this, I mean, when we say that, dependency, so we should, the main idea is that we should isolate the dependencies and we should be explicitly declare it, right? So you should declare it in such files like in requirement.txt for Python or package.json for Node.js. Similarly, what will happen with this is that it will eliminate the risk like of like version conflicts, ensure that all the dependencies are self-contained and they are available, right? So you should avoid any implicit dependency. So never ever rely on the environments to to provide any dependencies, right? Implicitly. So that can be a problem, because certain may have security issues, certain may have some restriction on the particular environment. So never ever rely on it. But when it comes to microservices, they are particularly designed to be quite independent and also stateless. So, and when you're isolating these particular dependencies from them, right, will you avoid some versioning problems which might occur, right? Or right, that's the approach. Okay. One other way is like containers are used, like Docker, if you have heard it. So it basically isolates the services along with their dependencies, basically, right? So this is one of the example. Now config, so storing some config related in the environment, like such as database URLs, credentials, API key, they should be stored in some environment variables and not in the exact actual code, right? So that is very important. Like now, earlier it used to be like many of them, the static or the content used to be in some static or variables, right? So we should avoid that using it because let's say your application is running on multiple environment, right? The feature and production. Now, how do you segregate or make the changes for the same code without making any changes? It should be run on the production also. It should be run on the dev environment also. So by making that tight the code in the changes, then it will be you have to every time when you are trying to deploy, you have to make the changes, right? So that's the separation of configuration from the actual code. So the configuration can be changed without you have to deploy it or you have to change that particular code base, right? So same code will be available and it is already deployed. It's a matter of changing the configuration, restarting the services, right? So that's one of the benefits. Now, what happens to when it comes of microservices? The microservice often is dependent on the different configurations for different environment, right? So like say production development related database configurations are different. Now storing in this particular environment variable ensures that it will be quite flexible and also it is not environment restricted, I would say. So backing service now you should have a any services, let's say, that is actually that app relies on, right, such as like database or cache or API should be treated as an attached resource. So what does it mean? That it should be configurable and it should be I mean basically if it is configurable it should be some environment variable. So now what happens is that the microservices which can be binded dynamically so to a certain extent resources like database where messaging system or you have some third party API. So it is quite flexible and which ensures that it maintains its flexibility. Now, in microservice context, right, each service is often communicate. So to different APIs, right? So we normally have another services which we wanted to get some info, right? So you should treat this particular services like an external dependency. So it is quite, I mean, it is beneficial. It is quite easy to scale up, right? So switching from the and upgrading and service independently, there is an advantage of it, right? So you should not be thinking of making any changes, right? So that's the advantage. Now build, run, release, and run. Now basically, you should have very separate processes for a build and run for this particular stages, right? So this methodology, what we are discussing about is between the separation of the build logic and the one which is stage running the logic. So when we say build, right? So it is basically compiling it, installing certain dependencies, right? But when we are saying running, right, we are actually executing that particular app, right? So there should be a proper release management. The code should be deployed using via CI/CD pipeline, and then it has to be deployed in certain production environment so that it doesn't make any changes of the state of the application. Right? So it is all maintained and it is actually exactly the same throughout the other environment. Now, when it comes to microservices. each services can be built on and deployed independently, right? So that's the one of the important factor of microservices. So decoupling the build and the release process, it will ensure that there are certain bugs which are caught pretty earlier only, and this service can be deployed without any downtime requirement. So as these are independent service and autonomous, you can use that. Now there are processes, I would say. Now there are one or more stateless processes which has to be executed in the applications, right? So stateless is what exactly, it will not store any data in the memory or anywhere, right? So that's what exactly the stateless means. So when you're requesting something between the application, so the request, this particular data will not be stored between the request, right? So any data which has to be stored externally or in the backing service, that should be either stored in databases or a cache, right? So there's a term called ephemeral. So that basically means that the processes can be restarted, right, scaled up, and then replaced, so that it is not only impact the other system. So your system should be designed in such a way that, or processes should be designed in such a way that it is not impacting the external systems. Now, stateless is one of the important feature, I would say, when it comes to microservices, right? So as microservices are independent, right? They are particularly designed so that it can be scaled up and it can handle many more requests or millions of requests by actually adding some more stateless application instances, right? So you can scale it. Now, port binding. Now, we should have an services that should be binded using the port, right? So now you should not rely on an external some web servers, right? Like Apache or Nginx, right? So instead, you should be exposing your application to an HTTP port, either 8080 or any other protocol directly. So that's the port binding, right? So it is one thing which makes your services to run on its own, and also it will have a different environment. So handling the web requests which are coming as an incoming shell, that can be handled independently, right? So in terms of microservices, you have some REST APIs exposed and GPRC API via HTTP or any other protocol which we can use. But these are all self-contained, and they does not rely on the external servers to process that requests, right? So that's the advantage of port binding. Now concurrency, this is one of the I would say scaling feature, I would say. So microservices are designed, as I mentioned, to handle multiple concurrent requests where the application running processes those requests, right? So you can actually scale any applications by adding a number of processes or instances, right? So what happens with this is that you have more workers, and you have your architecture is in such way that it is an event-driven architecture, so that it can handle multiple concurrent requests, right? So multiple requests can be handled when you wanted to serve that request. So now, and as I mentioned, microservices are typically stateless, so it can be, and it is developed and deployed independently, so it can be scaled also independently. So we can split the monolith application into a smaller concurrent unit, so that it become easier for us to load that, and we can increase the number of instances for that particular services so that it can handle the load. Now disposability. So the idea is fast startup and also the graceful shutdown. So any application that is designed to start your application, the microservices or any of the application, it should be designed in such a way that it should be started very quickly, and also it should be shut down if there is a if you have to shut down your application, it should be shut down gracefully, not on a sudden on a sudden, right? So it should be quite resilient to that particular, if there is any failure system, then also it should allow itself to scale it. So there is a quite robust process management involved. So that what happens is that application which are has to clean up their resources, close the connection, finishes some task, right? So those can be terminated. So it will not be an ever-going process, right? So that should be quite robust. Now, in terms of microservices, this has to be that individual services, whatever it is, there has to be replaced, and also it should be quite scalable. It should be restarted whenever required regularly, right? And also it ensures that your services, if it is has to be shut down, it has to be gracefully shut down without impacting any other resources. So that is quite important when it comes to be your application to be highly available. Now dev or a broad parity. So this means that you keep the development and the staging environment as similar as possible, right? So uh, the idea is to avoid any significant differences between this environment, so that the many situation occurs like the developer says that in my machine it is working and there it is not working. I don't know what is the problem, right? So consistency is quite important, and when you're developing something, it should be running exactly same whether it is deployed anywhere, right? So you should have that particular consistency with the dependencies on the services also, so that whether you're developing it or whether it is deployed in the production, right? So it is having the same dependency, same configuration, and whatever the required configuration. Uh, so it can run properly, and also it can also backtrace some issues. Let's say in the production the application went on and there are some issues has been raised up. So ideally if it is raised in the production, ideally it also means that the same thing can be reproduced in the dev environment as well, right? So there is a high possibility. So microservices are often they rely on different configuration for dev, production and other, right? So these are all having different services. So you should your application should function similarly with internal configuration related changes, right? So that should be the idea. So so you can treat the logging as an event stream. So what happens is that when you treat your logging as an event stream, it should write your logs to some certain standard output, and it should not rely on certain files or local things, right? So there should be a standard process. So you can actually aggregate certain logs in a certain location, so that it can be collated in one location, and also it can be aggregated and shown in the log management system, so that we can monitor our application, we can troubleshoot something. Okay, if you wanted to monitor something, the application is running or not properly, we can look at it, right? So it should be centralized. So many organizations, this logging is centralized, so that let's say you must have heard of ELK tech stack, right? So this is one of the way where you can actually aggregate the logs and then view and search the logs, right? By constantly monitoring if there is an exception happening, you can analyze what is happening, the logs, right? So it's quite helpful where your application is distributed, right? And it's not locally running. Admin processes. Now, this is one of the important aspect when it comes to admin or like management of your processes or the application, right? So any task which has to be executed, right? That like let's say for maintenance purpose, let's say there is any database migration, backup has to be taken. That has to be a separate process or one of the process. So these tasks has to be isolated, and also it should it should not be the part of the same main applications, right? So for a different environment, different similar things should be taken care. Let's say for production it should be different, it should be for development it should be different, right? So it can be executed and maintained. So in microservices architecture, the tasks like database schema migration, backup are often taken as an isolated process. So this job will not impact your overall application, normal application which is running, right? There is no impact on it. That should how it should be independent. I hope this particular video was helpful and you are able to understand what are the 12 factor apps methodology, and this video is helpful when it comes to learning designing the robust and scalable application. Also, if you are attending any interviews, right? So many interviews you will see this particular question, and this is has been a trend where particular question is definitely asked one another time. So this will give you an edge over the other people who, if you already know the concept and if you have thoroughly gone through this particular video. Please don't forget to like, subscribe, and hit the bell icon. If this video was helpful, please share it with the other needy people. Uh, Thank you. Thank you for